Okay, for the first problem on page 233, I did problem 5-2. Determine the horizontal and vertical components of reaction at pin A and reaction on the beam at C. So at pin A, there'll be a vertical and a horizontal reaction at pin A, and there'll be a force here going along this beam at C. Here's the beam, and here's the force going down, acting down. Okay, so I started off with my equilibrium equations with f of x equals 0. Here you would have f of x plus fc, which is the c component of the FDC force, and the x component of this FA. And then I can't solve for any components right there because those are two unknowns. So I went down to my Fy equilibrium equation, and here's the Fy from this acting on point A, and here's Fcy, which is the vertical component of this FDC, and the minus 4 kilonewtons is from this force acting down here. And here I solve for the moment, which Miss Harvey said you should usually solve for the moment first when you're solving equilibrium equations, so you can actually solve for the unknown, which I found out after I did it, and I remember that she said that. And here's the components for FCX, which is this, just listed out with the force. So that's this broken down into that, so you could substitute this for that. So we solve for Fcy, and then we get Fcy to equal 8 kilonewtons. And we take Fcy, f of sine 45, and we plug it in for Fcy. So f sine 45 degrees equals 8 kilonewtons. If you're wondering where I got the 45 degrees angle from, it's because this is 1.5 meters and this is 1.5 meters. So that means that these two angles are the same, and this is a right angle right here. So this is the 45 degree angle. It could be right here. And here's the triangle. So that, and then I solve for my FC right here, and here's the value of FC. And what I did next was I plugged my Fcy into equation 2, and Fcy equals 8 kilonewtons. So Fay plus Fcy minus 4 kilonewtons equals 0. And you solve that out, and you get Fay equals negative 4 kilonewtons. So that means that this Fay is acting downwards. And then we plug Fcx into equation 1, and if you can solve for Fcx and it's 8 kilonewtons, or you can just say it's 8 kilonewtons because they're both 45 degree angles, so it would be the same value. So you plug your Fcx in, which is 8 kilonewtons, and your f of x is negative 8 kilonewtons. So here's all the answers listed right here. For the next question, on page 261, I did problem 5-7. Uniform plate has a weight of 500 pounds. Determine the tension of each of the supporting cables. The first step I did was to list out the equilibrium equations. So the forces of the entire system are all acting in the z direction. So the FB is acting up here, plus FC, which is also acting up, plus TA. They're all tensions, so they'd be acting up. and TA. And the forces are acting down is the 200 pounds and the 500 pounds. So minus those equals 0. And here's the moment about X. And we take the moment from this point here. So TA is 3 meters, 3 feet from the moment we're taking from. And TC is also 3 meters over. Negative 500 pounds is 0.15 because half of 3 is 3 divided by 2 is 1.5. So half of this is 1.5, and 500 pounds is in the middle of this component. So 1.5, and the 200 is acting at the edge, so it would also be 3. And then you solve for your moment about the Y acting from this spot. You have your, okay, I'll explain why these are positive over here. TA 3. So this would be going around in a counterclockwise motion from the point at the origin. So it would be counterclockwise, so it would be positive. And it's the same with the TC. This would be going counterclockwise, and since these are going down, they would be going counterclockwise. So they're minus, they would be going clockwise. This is clockwise, and this is clockwise. MY, here's negative TB 4, and TB is here. And it's negative because it's going up and around, so it would be going clockwise. So it would be minus TB 4 feet. This is 2 plus 2 is 4. Here's TC, it is also 4 feet away. So, and it is also going around the origin in a clockwise motion, so it would be negative TC times 4. And with the 500 pounds, it is 2 feet away from the Z, the Y-axis, so 500 times 2, and it would be going counterclockwise, so it would be positive. And this is also the same distance from the Y-axis, so it would be 200 plus 2, or times 2, and it would be going counterclockwise too, so it's positive, and it would equal to 0. And you could simplify both these equations. You divide this one by 3, and you get TA plus TC minus 250 minus 200 equals 0. And you could simplify this equation by dividing it all by 4, and you get negative TB minus TC plus 250 plus 100 equals 0. And here I have them all listed right here. And what I did, I used equation 1 and 2, and I took TA plus TC equals 400 and plugged it in to the first equation to like this. TA plus TC equals 450 kilonewtons. So TA plus TC, and here's equation 1. You can just substitute TA and TC for 400, and TA plus TB equals 700, and then you can solve for TB using that, and you get your TB to be 200 pounds. And with your TB is equaling 200 pounds, you can plug in your TB into your third equation here and solve for TC. That's what I did. TC. 350 minus 250 is 100 pounds. And you plug your TC value into equation 2 to solve for TA. So 450 minus 100 equals 350 pounds. And those are all the answers.